So this is another example of Rayleigh's method. So here is one uniform cantilever beam, but the beam also has a mass of m subscript L. So beam also has a mass of m suffix L and has a concentrated mass m at its free end. This is capital M. Let us make it capital. So this is capital M. Its free end. Determine the effective mass of the beam to be added to capital M, assuming the deflection to be that of a massless beam with a concentrated force at the end, and write the equation for its fundamental frequency. That means here see, the deflection at any point is y, x, t. That is, it is a function of x and also a function of t, and the function of t is actually a sine function, and at this point the deflection is y. In place of x we have to put L, t. So let us now write that, let us make it green. So y at L t is some amplitude y L into sine omega n t, because it vibrates with its natural frequency. This is the amplitude and this is the time function, and yxt is nothing but this capital Y at x sine. So nice. Okay, now in Rayleigh's method what we do is we assume that the deflection at any point or the motion at any point can be expressed in terms of a single point, and here it is the point where capital M has been placed, that is the tip mass has placed. That means this yx has to be represented in terms of this yl. So how can we do it? So they advise you to take the static deflection curve of a massless beam with a concentrated force at the end. So this, and this is the equation of the static deflection curve. So from here you get that y at L is equal to P L square by 6ci 3L minus L, so 2L, so this is PL cube by 3EI, and this is y at x. So y at x is y at x, so let us do it like this, it would be better, by y at L is equal to px square by 6ei into 3L minus x divided by PL cube by 3EI. So this PP goes, so this becomes so this is actually into 3EI by PL cube. So PP goes, EI goes, 3 goes, 2. So this is x square 3l minus x divided by L cube or 2L cube. So 2L cube. I think it's okay. So 3i L cube. So PP goes, L cube remains, x square 3i is 2, so 3l x square 3l. So from here we get the relation that yx is equal to x square into 3l minus x by 2l cube into yl, and this we call fx. So this is dimensionless square. Yeah. So now once we get this, so let us take this figure here. Let us take this figure here in the next page. So now what is the kinetic energy of this portion? So the kinetic energy is dt is equal to half if we take m suffix l, so this is half ml by l, and if it is m multiplied by l, then it should simply m. I don't know, it's m multiplied by l. Okay, then what we should do is we remove this and we take mass per unit length as ml by l. So mass per unit length is half m. So mass per unit length is half m into dx into y dot xt square, and that means it is half m dx, that is what is this is yx square into y dot, that means yxt is yx cos or sine omega n t see. So y dot xt is this into omega n square cos square omega n t. So and this is half m dx, so this is fx square into yl square omega n square cos square omega n t, and if you take dt max, Okay, let it remain. So T is equal to, so you integrate half m omega n square cos square omega n t, from here yl square, and m is fx square to dx 0 to L. So this is the kinetic energy due to the beam, and T total would be this plus, so half m omega n square cos square omega n t yl square 0 to L fx square dx plus half this tip mass m omega n square cos square omega n t yl square. So now if you take the maximum value, this cos square omega n t will become 1. Here cos square omega n t will become 1. So with capital M you have to add this small m into this. So T total max is equal to half into m plus small m into 0 to L fx square dx. Omega n square y L square, and this is the extra term which you get in the mass. And once you get this fx, you can integrate it. Once you get this effect, you can integrate it. I think this is correct, so you please check it. So this is actually the correction mass, and in omega n is equal to k by, or omega n square equal to k by m plus m 0 to L fx square dx, where k is equal to 3 ei by L cube. Because if you, for a beam, you know that if you give a force, then the deflection at this point is delta equal to PL cube by 3ei. So here PL cube by 3ei, so P by YL is equal to 3ei by L cube. So for the stiffness you can take 3ei by L cube. So this is the correction term you add. So let us stop here.